Hello friends, welcome back to the lecture series on high voltage engineering. The topic for today's discussion is testing of isolators and circuit breakers. If I just compare isolator, which is represented as a switch, maybe a single throw switch or a double throw switch. So if this is the position of opening and this is the position of closing, this is the moment of opening, this is the moment of closing for isolator. So this is one kind of isolator, this is second type of isolator. If I compare it with the circuit breaker, the circuit breakers are represented for the different types of circuit breakers in this manner. This is what the symbolic representation of a circuit breaker. Circuit breaker is also a switch. So the characteristics of both isolator and circuit breaker is same, and therefore this particular unit, that is isolator and circuit breaker power system apparatus, is used in a single topic where we are going to study the testing on circuit breaker and isolators. The testing of isolators and circuit breakers, that gives the common characteristics that is applicable for both. While these characteristics are not much relevant to the circuit breakers as far as the testing of isolators are concerned, since isolators are not used for interrupting high currents. They basically used only to interrupt the low or small currents of 0.5 ampere for rated voltage of 420 kilovolt and below. The isolators are basically used to interrupt small currents like capacitive currents of bushings or bus bars, etc. An isolator is a mechanical switch. For that, you can refer these two diagrams, figure 1, figure 2, and that is capable of opening and closing a circuit. Isolators are basically capable of carrying currents under normal circuit conditions and for a specified time under abnormal conditions such as short circuit. So the testing of circuit breakers is mostly discussed. The testing of circuit breakers evaluates constructional and operational characteristics and electrical characteristics. So we have the categorization of the testing of circuit breakers as electrical characteristics, physical characteristics, and other characteristics. In electrical characteristics, that determines the arcing voltage, current chopping, residual current, rate of decrease of conductance, shunting effects in interruption, etc. So these kinds of parameters or the characteristics are studied in electrical characteristics. In physical characteristics, that includes the pressure developed at the point of interruption, the speed of contact level, the number of breaks, the size of arcing chamber, the materials and configuration of circuit interruption, etc. are going to be characterized or tested in physical characteristics. In other characteristics, like the characteristics of circuit, that includes degree of electrical loading, applied voltage, the type of fault which the breaker has to clear, the time of interruption, the time of constant of natural frequency and power factor of circuit, the rate of rise of recovery voltage, restriking voltage, decrease in AC component of short circuit current, the degree of asymmetry or DC component of short circuit current. All these are tested and characterized or studied in other characteristics. Now, to assess these above factors, the main tests which are conducted on circuit breakers and isolator switches are: first, dielectric test, impulse test, temperature rise and mechanical test, and short circuit test. Now, these tests are studied in detail, starting with the first test, that is dielectric test. In dielectric test, which also called to be the over voltage test, and it is similar to the testing which we have studied for other equipments. So in this particular test, the circuit breaker of over voltage withstand test of power frequency, lightning and switching impulse voltage. It means that circuit breaker has to withstand on this particular over voltage of power frequency, lightning and switching impulse voltage, etc. The tests are done. So here I can mention that it is over voltage. That may be of power frequency, maybe of power frequency or high frequency. And high frequency is nothing but the impulse voltage. Tests are done for both internal and external insulation. For internal and external insulation with the switch, or switch is nothing but the isolator, or circuit breaker in both open and closed condition. So switch is nothing but the circuit breaker. Sorry, switch is nothing but the isolator, and then we have a circuit breaker. And it is to be tested for both the situations like open and closed condition. In open condition, the test voltage levels are 15% higher than the test voltage. 15% higher than the test voltage used when the breaker is in closed position. When the breaker is in closed position. So in fact, under closed position, the required test voltage is less, whereas under open condition, the required test voltage is to be higher. The reason behind that, under closed condition, the circuit breaker is closed or the isolator switch is closed, and therefore the breakdown occurrence under dielectric test is less. Whereas under open condition, the formation of that breakdown and hence the breakdown strength for checking the dielectric stress or dielectric test requires higher voltage, and therefore it must be 15% greater than the test voltage. Possibility of line to ground flashover, like under this particular test, the possibility of line to ground flashover is more. So to avoid the circuit breaker is mounted on insulator above the ground. Now, second test is called as impulse test. In this test, the lightning impulse wave of standard wave shape is given in a similar manner as in case of insulators. The testing of insulators we have already studied in the start of the lecture. So the testing of that insulator and the testing of isolator or circuit breaker is same. In addition, the switching surge test with switching over voltage are done on circuit breaker and isolators to assess their performance under over voltage due to switching operation. So whenever switching or lightning occurs, that brings the voltage called as over voltage, but specifically with the change in frequency, and therefore it is referred as the impulse voltage. So the testing on the insulator process is applicable to the circuit breaker and isolators. Circuit breaker and isolators. Then another test which is conducted is temperature rise and mechanical test. In this particular case, whenever the current occurs, rises the temperature, and there may be the chance of breakdown in terms of not only electrical but also the mechanical stress, that is mechanical breakdown. So therefore the type test on circuit breaker and isolators are done according to the specification. As per the requirement, these two tests, that is temperature rise and mechanical test, are conducted. So this is all about the test which we have considered: dielectric test, impulse test, and temperature rise and mechanical test. Now let us understand the fourth test called as short circuit test. Now this is the important test which is to be carried out on circuit breaker, since these tests assess the making and breaking capacity at various load currents and rated voltage on circuit breaker. We know the meaning of making and breaking capacity of a circuit breaker. It means the capacity of the circuit breaker during the breaking of the circuit and the capacity of a circuit breaker during making of the circuit. So there is need to put the circuit on online, which is to be done by making the connection of the circuit breaker. So the making and breaking capacity at various load currents and rated voltage is to be tested. In case of isolators, the purpose is to determine their capacity to carry the rated short circuit current for a small duration or given duration, and there is no breaking or making current test to be done on the isolators. So this particular short circuit test, which is to be conducted on both isolator and circuit breakers. But the purpose of conduction of this test on isolator is different than the circuit breaker. In isolator, there is no need to have that breaking and making capacity to be tested, but the only thing is whether that isolator is able to carry that short circuit current or not. But in case of circuit breaker, that particular test is conducted to check whether it is able to break the circuit and can make the circuit. Now, in this case, we are going to study the test referred as a synthetic test, that is direct testing in network or in the fields. So the first test is called as direct testing. Direct testing. In this direct testing in the networks or in the fields, says circuit breakers are sometimes tested for their ability to make or break the circuit under normal load conditions or short circuit conditions in the network itself, and therefore it is called as direct testing. Therefore it is referred as direct testing. This is done during period of limited energy consumption. As we are doing the direct testing, therefore it is to be checked the availability of energy. If the availability of energy is less, then it is good period to test the circuit breaker during or circuit breaker in network condition. Means the circuit breaker when connected in the network and that circuit breaker is checked. So this is done during period of limited energy consumption or when the electrical energy is diverted to other section. Means that particular section where the circuit breaker or is present, and we are not checking that particular circuit. We are checking that particular circuit breaker which is there in the line, and therefore whatever the energy is there, it is being diverted to some other section or to some other network, and the energy related to that particular network where the circuit breaker is checked is less. The advantages of this field test or direct test is that circuit breaker is tested under actual condition, whatever the conditions which are going to be achieved or whatever the conditions which are going to be there or occur in a life. Then special occasions like breaking or of charging current of long lines, short line faults, interruption of small inductive currents, etc. can be tested. Then it is to assess the thermal and dynamic effects of short circuit currents, to study applications of safety devices, and to revise the performance of test procedures, etc. So that is what the advantages of direct testing. But there are definitely certain disadvantages that is to be noted. The disadvantages are circuit breakers can be tested at only a given rated voltage and network capacity. If that particular circuit breaker is to be used for some other network capacity or some other rated voltage, then that it cannot be done, as that particular network is having that circuit breaker for a specific rated voltage and network capacity. The necessity to interrupt the normal services and to test only at light load conditions. As I said, that low energy condition is to be there. Then extra inconvenience and expenses in installation of controlling and measuring equipment in the field. So therefore, this is what the disadvantage of using direct testing. Then direct testing in short circuit test laboratories. So that can be done in the laboratories. For that purpose, you can refer this particular given diagram where we have a master or backup breaker. Master or backup breaker. Then there is a reactor. Then a making switch. Test device. CT, that is current transformer. That is also called as shunt. Then this is circuit capacitance. Then a short circuit testing generator. So this is that schematic diagram that shows the basic elements of short circuit testing laboratory. So this is first called as direct testing, and the other one which we are discussing is called the short circuit testing laboratory. That is, testing is done in the laboratory, in the lab. Now, in order to test the circuit breakers at different voltages, at different short circuit currents, the test, that is short circuit laboratories, are provided. The schematic layout of that is shown here. It consists of short circuit generator in association with a master or a backup breaker, reactor and measuring device that is test device. A make switch, this one, make switch initiates the short circuit, and a master circuit breaker isolates the test device, means this test device, from the source. So from this, it is breaked, or it isolates this test device from the source at the end of a predetermined time set on a test sequence controller. Also, the master circuit breaker can be tripped if the test device fails to operate properly. Master circuit breaker can be tripped if the test device fails to operate properly. Short circuit generators with induction motors or prime movers are also available. There is another circuit called as synthetic, or another way of doing the test called as synthetic testing of circuit breakers. So for that, refer this particular diagram. This is the schematic diagram of showing synthetic testing of circuit breaker. Synthetic testing of circuit breaker. So the purpose of doing this particular test is that due to very high interrupting capacities of circuit breakers, it is not economical to have a single source to provide the required short circuit and rated voltage test. Hence, the effect of short circuit is obtained as regards to the intensity of current and the recovery voltage as a combination of effects of two sources, one which supplies the AC current and other the high voltage. In the initial period of the short circuit test, the AC current source supplies heavy current. Like in this case, we have two sources, VC and E. Heavy current at low voltage, and then a recovery voltage is simulated by a source of comparatively high voltage of small current capacity. So this is that particular schematic that shows the synthetic testing. Now, what all equipments are present in this? Let us start with this. On this side, you can see there are numbers given. The number 1 is a master breaker that is already shown in the previous slide. Number 2 is called LC, that is a current controlling inductance. So this inductance is used to control the current. Then 3 is a main switch, and closing of that allows the testing. 4 is an auxiliary breaker, that is standby breaker. 5 is another coil called as LV, whose inductance is LV, that is represented as LV, called voltage waveform controlling choke. So it means there are two inductances used. One is LC that controls the current, therefore L suffix C Another controls the voltage, therefore it is L suffix V. Then there is a trigger gap whose triggers at a voltage of EV. So another abbreviations which are used here as T, that is nothing but the circuit breaker called as taste circuit breaker. VC is the low voltage high current generator. CV, capacitor charged to EV to give necessary recovery voltage. So it means there are two sources available. CB, that is capacitor. This is C0. C0, that is capacitor to control the frequency of the transient recovery voltage. That is C0. So these all are the abbreviations which are explained in the diagram. So with the auxiliary breaker, that is auxiliary breaker, that is 4, and the test breaker T closed. So this is closed. This is closed. The closing of the making switch 1. So when it is closed, making switch 1, that is master breaker 1, causes the current to flow in the test circuit breaker. So that current is represented as IC. IC. At some instant, say T0. Now we are going to see the waveform also, as this particular testing is used for synthetic testing, and this arrangement is used in the laboratory for synthetic testing. So therefore, we are going to check the waveform also for the generation of short circuit current. So initially, I am just referring, this is the instant of T0. The test circuit breaker T begins to operate, and master circuit breaker, that is 1, becomes ready to clear the generator circuit. So now this particular breaker is ready to clear this source. It means if it operates, it breaks the contact with this supply source, so that disconnects the supply to this testing circuit breaker. At some time T1, just before the 0 of generator current, the trigger gap 6 closes. As this gap closes, it means you can see here there is a gap. Here there is a gap. And when this particular point is pushed here, the gap gets reduced. As soon as the gap gets reduced, the formation of spark takes place. So at some time T1, just before the 0 of the generator current, the trigger gap 6 closes, and the higher frequency as it sparks, which is a similar kind of a frequency of switching and impulse. So higher frequency current from the discharging capacitor CV also flows through the arc. So I just show you this particular diagram where we have a T0, that is already said. T0 is the time. So at some instant T0, the test circuit breaker T begins to operate, and the master circuit breaker 1 becomes ready to clear the generator circuit. At some time T1, so at some time T1, here we can see that just before 0 of the generator current, So that generator current is nothing but the short circuit current, or we can say it is generator current IC. It is generator current IC. So at some time T1, just before the zero of the generator current, the trigger gap 6 closes and higher frequency current from the discharging capacitor CV also flows through the R. At time T2, now this is that time T2. So this is that time T2. So at this particular time T2, when the generator current is 0, here the generator current IC is 0, the circuit breaker 1 clears that circuit. That circuit breaker 1 clears that circuit, leaving only the current flow from CV. So we get only one current which is from CV, that is IV, which has the required rate of change of current at its zero flowing in the circuit in the test circuit breaker. So we have only one current which is flowing, that is IV. That is IV. So therefore it is that particular point, and therefore we have only one current passing, that is IV, at point T2. So at point T2 we have only one current passing through that test circuit breaker, that is IV. So as this particular point 1 is opened, the capacitor, due to this spark gap closing, that is trigger gap closing, the current passes through, that is high frequency current passes through this particular test circuit breaker. At the zero of this current, means IV, full test voltage will be available. So it means only voltage is available. The closing of gap 6 would be a little earlier in time than shown in the diagram, in the characteristics. But it has been drawn as shown for clarity at current 0. It has shown only for clarity of current 0. So it is important to see that the high current source is disconnected and high voltage source applied with absolute precision by means of an auxiliary circuit breaker. By means of an auxiliary circuit breaker at the instant of circuit breaking. That is at the instant of circuit breaking. So this is what the way of doing the synthetic testing under the short circuit test. So short circuit test basically classified into 3 categories: direct testing in the network, that is in the field; direct testing in short circuit test laboratory; and synthetic testing of circuit breakers. Hopefully you understood the concept of this testings on isolator and circuit breaker. So thank you so much guys. Take care.